getting some questions on the homework in Chapter 6, specifically 6B. So I thought I'd just run through a couple of the types of questions that I'm getting questions on. In particular, it seems like people are stuck, especially with, like this is question 1 here, part D, where they give you a percent, or like in question 2, where they give you a percentile, and they want you to come up with a data value. Okay, so I know that seems to be causing some problems for people. But before I get there, this is just question 1, and again, I realize that your question 1 might have slightly different numbers, but it should give you an idea of how to attack the problem. So in question 1, they tell us, this is 6B, question 1, they tell us that the average is 2.9 hours. And suppose that the standard deviation is 1.7 hours. And we are to assume that this is a normal distribution. Okay, so because they tell us it's a normal distribution, that's how we know we're allowed to use a normal CDF or an inverse norm, but we do have to know that a story that they're giving us is normal. Now, how do we tell whether something is normal? One way is that they point blank tell us, like we're seeing in problem 1 here, okay? So in part A, they're saying, what is the distribution of X? They say X is approximately normal. So when they're using this notation, the first slot, they want to know what the mu is, and in the second slot, they want to know what the sigma is. Okay, so it's just as simple as typing in those 2 values. Okay? And I don't think there was much of a question there. It was more on the B, C, and D that people were a little bit stuck. So find the probability that the child spends less than 1.3 hours per day unsupervised. Let me move this down here. I strongly, strongly encourage that you draw this picture that I'm going to be drawing. Every single one of these problems in Chapter 6 and 7, I draw a picture for. If you haven't done the worksheet yet, the worksheet, when I made the key, every single one of my worksheets had a little sketch, a picture for what's going on, okay? If you can draw the picture, there's way less items that you have to actually memorize. Draw a picture, okay? So in B, we know that we have a normal curve. We know that dead center is whatever your mu is, which in this case is 2.9. Okay, that's dead center. And we want to find the probability that the child spends less than 1.3. Okay, now keep in mind, this is a number line along the bottom. It's a number line, okay? So if 2.9 is right in the middle, we know 1.3 is less than that, so it better be somewhere to the left. Now, where to the left, honestly, it doesn't really matter. How to scale you are doesn't matter, but putting it on the appropriate side, on the left or on the right, is important. And then because it says less than 1.3, we are actually looking for the probability of this area here, this blue area, okay? So I want to find that probability, that area. I know the total area under the curve is 1, so I know that area is going to be less than 1. I know it's going to be less than 0.5 because it's less than half of the curve. But how do I actually find what that area is? We have 2 techniques that you can use. One technique is you can convert these x values into z values and then go to a table. I'm going to guess that very few of you like that method. I'm guessing the majority of you would like to use the second method, which is the normal CDF. So normal CDF, it's located on your calculator in the same place that the binomials are. Okay, it's right. I don't have the calculator open on the computer, so I apologize there. But it's right in the second distribution button, kind of close to where the clear button is. So if you go second distribution and go the second one down, it'll say normal CDF. Do not use normal PDF. Okay, we want to use normal CDF. And the normal CDF is asking for 4 values. Okay, it wants to know, let me jot this down, the lower number, the upper number, the mu, and the sigma. Those are the 4 values that it's asking for after that black parentheses there. So looking at the picture on my bell curve here, looking at that blue shading, they want to know what is the lower bound of that shading. Okay, so in other words, where does it end on this left-hand side? Well, it doesn't. It continues on forever to the left. Okay, so what you should use here is a really, really big negative number. Now, if you want to use negative 9999999, a bunch of nines, that's fine. Our traditional way in the stats world to notate this is to do -1, and then there's an EE button on your calculator, -1 EE99. That's -1 times 10 to the 99th power, okay? Now, to get that E to come up, if you look on your calculator, if you look at the 7 key and look at the key above the 7 key, there's a comma, okay? On that comma button, right above it, like if you would push second, there's an EE, there's a double E. That's what you're going to be using for this -1 E99. Do not use the E that's above the sign button. Don't use the E above the sign button. That's not the right one. You want to use the double E above the comma button, okay? So that's your lower bound. Your upper bound is where your shading ends on the right-hand side, which is 1.3. And then your mu is just given in the problem, 2.9. And your sigma is given the problem 1.7. So you're going to type that into your calculator. What I did notice on the homework as I was looking at people's is make sure you round appropriately. Okay, this problem says to round to 4 decimal places. You should get a 0.1733. And remember, your problem might have slightly different numbers. Okay. Part C is going to be very similar. Again, draw a picture. What percent of children spend over 2.5 hours unsupervised? So again, draw a normal curve. You know that 2.9 is going to be dead center because that's the average that they gave you. And we want to shade in over 2.5. Well, we know 2.5 is going to have to be over to the left because that's smaller than 2.9. And if we want to shade in the areas of more than 2.5, over 2.5, we're looking at this area. That's a pretty large area. We know it's more than half the curve, so we know it's going to be more than 0.5. But to actually find that area, again, if we want to find the area under the curve, and it's a normal curve, we're going to use that normal CDF. So we are going to use normal CDF. And we have to tell it 4 values, lower, upper, mu, sigma. The lower, and this time is the 2.5, because that's as you move left to right, that's your lower end of the shading. And the shading continues forever to the right, so technically the upper bound is infinity. So you want to use something that's really, really, really large. You could use 999999999. Or by tradition in the stats world, we use 1 and then the double E on the calculator, 99. So when the upper bound is going forever to the right, you use +1 E99. If it's going forever to the left, like on part B, then it's -1 E99. So see the difference there. Your mu is still 2.9, your sigma is still 1.7, so that didn't change at all. And that should give you approximately 0.593. I was just cheating and using the key on the homework there, but let me actually type that into my calculator because it only gave me 3 decimal places, and it might be because the 4th one's a 0, but I just want to double check that. Yep, it's because the 4th decimal is a 0. They should include it anyway, but and then in this problem, you know, part B said find the probability, so we left as a decimal, but part C says find it as a percent. So you would just take this and move it 2 decimal places to the right, and we have our percent. Okay. And then part D of this problem is the opposite of part B and C. Okay, so kind of look at this in the big picture. B and C is saying find the probability, or find the percent, or find the percentile, okay? In D, they're giving you the percent and they want you to find the data value. That's the opposite, okay? If you are looking for a data value given a percent and you're going that opposite direction like that, you're going to be using something called an inverse norm. And it's located in the same place on the calculator. It's right below the normal CDF. And an inverse norm, you have to tell it 3 numbers. So normal CDF, you have to tell it 4. Inverse norm, you tell it 3. You tell it area to the left of the number that you're looking for, and then mu and sigma. So the main tricky thing with an inverse norm is finding that first value, that area to the left, okay? So there's my curve. I draw in every one. We know that the average is 2.9. You can put that number line across the bottom if that helps. And they're saying 74% of all children spend at least how many hours per day unsupervised? Okay, 74% of all children spend at least how many hours unsupervised? So in this case, they're giving you the probability of the shaded area, and you have to find the data value. So it's the opposite of what we're doing, okay? So the question is, when we have that 74%, where is it in the picture? So let me zoom out for a second. I'm going to actually draw 2 pictures here because I want to have us decide which one makes more sense. So they're both bell curves, just a little sketch. And the question that I guess I'm posing is that 74% going from the left to a certain number here, where that area is 0.74, or is it going from the right and ending at a certain number here? So am I looking for the first picture, or am I looking for the second picture? Okay, and that's where students have the most trouble. They don't know where to put the percent, okay? In some problems in this section, they'll say the percent is in the middle. I honestly think those are a little bit easier, although the calculation is longer. But when it gives you something like this, this is where people get stumped. They don't know whether it's on the left-hand side like this or on the right-hand side, okay? Now, let's say you're completely stumped at this point and you're not sure which way it is, okay? One thing that you could do is try it both ways and see which way makes sense, okay? See which way makes sense. So let's just try that and see if we can make sense of the answer. So inverse norm, if I was looking for this x value right here, the area to the left of it would be 0.74. Okay, whereas if the bottom picture was the picture that was appropriate, the area to the left would be this area, which is 1 minus 0.74, which is 0.26. So if the bottom picture is appropriate, we would be doing this, okay? So I'm just trying to pose the way that if you're looking at this and you're thinking, well, I don't know which way is the right way, think of it this way, okay? So type in both of these into your calculator. And again, this inverse norm is located the same place as the normal CDF. If the first picture is right, you would be getting an answer of 3.99 hours. So I'm going to put a question mark by that. If the second way is right, give me a second to type this in, you would be getting an answer of 1.81, let's say 806 hours. Okay, so question is, which one is appropriate? Which one makes sense in the context of the problem? Okay, well, think about it this way. On average, 2.9 hours these kids are spending unsupervised. So if we want to find a number so that 74% of kids spend at least that many hours